Hello dear EAPCET aspirants, welcome back to NEET WORLD. So in this session we will be discussing solutions. Okay, so one of the very easy and interesting topic, and there will be two questions from this solutions chapter in the final EAPCET exam as well as in your JEE and NEET also. This is very important chapter. Okay, and here I will be telling you the questions mostly comes from very few selected topics. Okay, let us first of all let us segregate what are the topics we need to focus here first when it comes to solutions. ఈ చాప్టర్ లో మనం ఫోకస్ చేయాల్సిన ఇంపార్టెంట్ టాపిక్స్ ఏంటో ఫస్ట్ ఒకసారి లిస్ట్ అవుట్ చేద్దాం. ఫస్ట్ ఆఫ్ ఆల్ ఈ చాప్టర్ లో మనకి what do we mean by solutions, and after knowing solutions అందులో నుండి మనకి టైప్స్ ఆఫ్ సొల్యూషన్స్ తెలియాలి. టైప్స్ ఆఫ్ సొల్యూషన్స్. ఓకే, అండ్ దీని తర్వాత see especially this series, I mean we are almost started this from November 1st. It is almost 15 to 16 days, it is over already. Okay, so I hope you are following our sessions every day for your upcoming EAPCET. Okay, మీరు అందరూ కూడా EAPCET 2026 కి ప్రిపేర్ అవుతున్నట్టయితే మా పర్టికులర్ ఛానల్ని, మా నీట్ వరల్డ్ ఛానల్ని you should follow every day so that you will definitely get benefited out of it. Okay, because we are conducting free live sessions with very effective way of presentation. See, we have solved all the PYQs almost for each and every chapter. I am at least taking some 30 to 40 or around 50 questions I am using for every chapter. Okay, so 30 to 50 questions I am using for covering all the subject, I mean all the like important topics of each chapter. Okay, so look at here, in this chapter also I am going to cover at least some 30 to 50 questions. Okay, so first of all look at this, you need to understand what are the types of solutions we have, and the next there is something called concentration terms. Okay, concentration terms, something like molarity, normality, those things are there now. Yes, there you need to focus, and particularly when it comes to solutions you need to know about Henry's law. So what is the use of Henry's law? Henry's law says solubility of gas in the liquids. Okay, this is one of the important topic. And after this, vapor pressure versus temperature. Okay, what is the effect and what is the relation? Okay, that is what Clapeyron equation we will say. Okay, and after doing that we need to discuss about Raoult's law, and after discussing Raoult's law you need to know about ideal solutions, non-ideal solutions. What I am saying, ideal solutions and non-ideal solutions. And once after knowing this ideal and non-ideal, from this non-ideal solution, ideal solution, what are the examples we have? Very important, they will give simple examples, they will give and they will ask us to identify. There is not even a single second of time will be wasted, because just by looking at the example without solving anything only we can identify them, right? So here we can save our time in the exam, so that's why we need to focus on these two things also. Once after knowing non-ideal solutions, here something we have called azeotropic mixtures. What is that? Azeotropic mixtures. Okay, and azeotropic mixtures and their types, these are the another thing we need to look into it. Okay, and after okay, Lohit in the chat box, hi, good evening. Yes, look at this, what I am saying, Raoult's law, and Raoult's law is applicable for ideal solutions only. Then we have non-ideal solutions. So in non-ideal solutions we have azeotropic mixtures. Okay, we need to focus on that also. Okay, they will ask us to identify which are the following show minimum boiling azeotrope, maximum boiling azeotrope, and after that we need to focus on colligative properties. Colligative properties. So what are the colligative properties we have? RLVP, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. These are the 4 colligative properties we have. We need to focus on this colligative property. So in this exam, in the exam, you can expect one question definitely from concentration term, definitely one question, okay, from concentration term, and one more question might be from any of these 3 topics. Okay, so more specifically we can say colligative properties, there are majority chances, or any of these 3. Okay, all these topics are very easy and conceptual only. Okay, so nothing to feel difficult when you are learning these things. Okay, so today we will be covering this Henry's law. Today I will be covering this Henry's law and few concentration terms. Okay, because on concentration terms already I made videos in the YouTube. Okay, that's why. Let's see, first thing here, what are the types of solution? First of all, define solution. So solution doesn't only mean that it should be always in the liquid state. It can be solid form, or it can be gaseous state, or it can be a liquid state also. Okay, so now what is mean by solution? First of all, say we have, when I am taking 2 components, component A and component B I am mixing. Okay, so the resultant mixture is there now. If this resultant mixture is homogeneous, what I am saying, the resultant mixture is homogeneous, then we can say it as a solution. See, look at this, a homogeneous mixture of 2 or more pure substances whose composition may be altered within the certain limits is termed as solution. So what is this? It's a homogeneous mixture of 2 or more components, simple. Okay, it's a homogeneous mixture, you can remember. Okay, for example, I am making sugar solution. What I am making? Sugar solution. So for this purpose, what we should add? Sugar into water. Right now, so we are adding sugar into water. So generally sugar will be in solid form, okay, and water will be in liquid form. Sugar solution means this is also in liquid form. Physical states you know now, gas, liquid, solid, right? So now in solution there are 2 parts, one is solute, another one is solvent. So what I am saying, in order to make solution we require 2 parts, one is solute, another one is solvent. Now here I am giving you sugar solution, identify which is solute, which is solvent here. So now how can we identify? First of all, look at the physical state. Solution is having liquid state, then the one which is having same liquid, same physical state as our solution, consider as solvent. Okay, so this water and solution are having same liquid state, same physical state, so this I can say solvent. What is the first point? How can we identify solute and solvent? Solvent and solution will be having same physical state. This is the first primary thing to do. Okay, so em cheptuna, solvent and solution should have same physical state, then we can say it as solvent. The one which is having same physical state as our solution is considered as our solvent. For example purpose, one more for more clarity, see, I am saying sugar syrup. What I am saying? Sugar syrup. Sugar syrup generally how it will be? Water and liquid state only, no? So I am writing liquid. Okay, so in order to make this sugar syrup, we definitely require sugar plus water right now. So water again in liquid phase and sugar is in solid. But in this sugar syrup means there will be maximum content of sugar, like around 60% sugar, 40% water will be there. Yes or no? Yes. That's why we are saying sugar syrup. Okay, so now I am not saying which is major quantity. I am saying what? Look at their physical states first. The one which is having same physical state as our solution will be considered as a solvent. So what is our solvent in this? H2. Water is our solvent. Okay, this is our solvent. Hope this is clear.
If we consider state.
We need to consider state only first. What is the first factor to identify solute and solvent? Look at their physical state. The solution and solvent should have same physical state. That's it. Okay, right. Next, what if solute, solvent, solution, all of them are having same physical states? What is the second way I am taking? Second case I am taking, all of them are having same phase. Solution, let us say liquid state. Solvent and solute, let us say here I am taking ethanol plus water. Ethanol plus water I am taking, so we will get alcoholic solution. Alcohol solution will get ethyl alcohol solution. Ethyl alcohol solution will get. Ethyl alcohol solution will get. Okay. Now how can we identify which is solute, solvent? See, all of them are in liquid state only, na? So very simple. In this case, if the physical states are same, consider one which is having weight by weight percentage as maximum, that will be considered as solvent. What is the second way of identification?
Weight by weight.
The one which is having more weight by weight percentage is solvent. Okay, right. Is this clear or not? First one is physical state, second one is weight by weight percentage. Hope this is clear, right. Let us move forward with few more discussions. Yeah. Now types of solutions, if we observe, see our solute, solvent. If I fix a solvent as gas, solute can vary. Now tell me solution is of which type? Since solvent is gas, solution also in gaseous state. Right now. So what are the examples we have? So gaseous solution if I take, solvent should be, in order to make gaseous solution, solvent must be gas. We can fix it as gas. Now solute can be a gas, can be a liquid, can be a solid. Now what is the example? In the exam they will give like this, mixture of mercury plus sodium is an example of which type of solution?
Liquid and
let's make it clear. Once after understanding this, you can easily answer this. Okay. So now gas plus gas, it means solute is gas, solvent is also gas. So we can say gas in gas simply. So what is the example? See, this is a gas in the atmosphere we have. So air, like nitrogen gas in the,
oxygen.
In this air. Okay, or oxygen in nitrogen gas. So this is a mixture is nothing but air in air, gas in gas now. So you can say mixture of gases is the best example. Air is the best example for gas in gas type of solution. Next, solvent can be gas, solute can be liquid. So what is the best example? Water vapors in air. Like water vapors.
Water vapor is
gaseous state. See, solute is water. Water vapor in gas. What happens? This is an example of resultant will be in which state? Gaseous state only, na? Vapor phase means gaseous state only, na? So that is an example of gaseous solution having liquid in gas type. Okay. The next, solid means what? See, you take camphor or iodine, they will directly converts from solid state to gaseous state. So if I say camphor in air, what I am saying? Camphor in air or iodine in air. So now what happens? That camphor or iodine, which is solute, converts directly into
solid.
Which is solute, that is solid, converts directly into gaseous phase. So we will get solid in gas type of example from here. Okay, right. No, Akshay Verma, this is not a pre-recorded. Right now I am teaching in a live. Yes. Next, similarly, both can be like liquid. Again, now we have liquid phases, everything. So gas in liquid. Gas in liquid means, cool drinks, carbonated water we'll say. What they will do? They will pass CO2 gas into the water with high pressure. So CO2 dissolved in water. So we are making it a soft drink. So which state it is? Liquid state now. So it means what is our solvent there? What is that? Water. Okay, water. Okay, and solute is CO2 gas. Or again other ways I can say oxygen dissolved in water is also an example of gas in liquid type of solution. Okay, next mixture of two liquids like ethyl alcohol in water is an example of liquid in liquid. Next, salt in water is an example of solid in liquid. It means salt is our which is in solid form. When we dissolve in the water, it will make a salt solution which is in liquid state right now. So it means liquid, solvent, liquid, solution. Okay, that's it. Next format we can have a next type is what? Solid in gas, solid in liquid in solid, solid in solid, like this we can have. See, gas in solid, this is an example. We will be using hydrogenation of alkenes. There the catalyst used is what? Metal surface with hydrogen gas. So here you can see adsorption of gas on solids. For example, I have a palladium or platinum metals. On this I am passing hydrogen gas. Now what happens, this hydrogen gas will accumulates in the pores of this metal surface. Okay, therefore that looks like a solid form. That resultant solution looks like a solid form. Only single phase is observed now, homogeneous. So it means it's an example of gas in solid. Okay, right. Next, solid and liquid. This composition is, see, mercury is in liquid form. When we add it to zinc metal, it will form zinc amalgam. Or if I add to sodium metal, this zinc metal, sodium metal are in solid forms. When we add this liquid mercury, what happens? We will get amalgams. So these are having solid forms again. Okay, so these are example of liquid in solid. Next, solid in solid examples you tell me. Solid in solid means you just mix two metals. For example, we are making gold ornaments. What they will do? They will add little amount of copper to the gold. So this is an homogeneous mixture of two solids now. That is an example. Okay, homogeneous mixture of two metals. See, best examples are alloys. Alloys like brass, bronze we are saying now. See, bronze means it is copper plus tin. It's a homogeneous mixture of two metals, solid and solid. Okay, metal alloys are the best example of solid in solid type of solutions. You can remember. Okay, so they will ask giving different types of examples. It is an example for which type of gas, which type of solution they may ask. Okay, or they may give like this. Brass means this composition you need to remember. Okay, next, tin. Next, solubility of gas. Again, this is very easy and interesting. Solubility of gas. Generally, what happens? Consider I have liquid here. What we have? Liquid. So I am using a pipe. I am passing gas into it. What we are passing? Gas. So now what happens? This gas is passed with high pressure. What happens? Some amount of this gas might be soluble in the liquid. Okay, now what I am saying, solubility of gas in the liquids. Okay, solubility of gas in liquids. So this is betterly explained by Henry's law. Who explained this? Henry's law helps us to understand solubility of gas in liquids. So what is this Henry's law says? See so here it says the solubility of a gas is directly proportional to its partial pressure of that gas. What I am saying, it's partial pressure. Okay, if more is the pressure of that gas, more is the solubility. For example, I have mixture of gases here. What I am saying, I have mixture of gases. For example, I am saying here N2 gas is there, and the next CO2 is gas is there, and along with this ammonia gas is there. This is a mixture of gas. Now I am forcing these gases to soluble in this water. So which gas will be having more solubility? Tell me first. This is a basic understanding. So the solubility of a gas depends upon their intermolecular forces. What I am saying? If more intermolecular forces, what do we mean by intermolecular forces here? More attractive force with this water. See, water is a polar now. Water is a polar. The substance which is having more polar nature or more intermolecular force, attractive forces this water, that will more soluble. So now look at this ammonia. Ammonia can have hydrogen bonds. What I am saying? So nitrogen, which is more electronegative than hydrogen, creates polarities like this. So due to the rise in polarities, water is also having polar bond like this. So there will be partial negative charge on oxygen and this hydrogen. So this is the reason what we can call it as hydrogen bond. So due to this hydrogen bond, intermolecular forces are more between ammonia and water. Therefore solubility of which gas is more? NH3. So once you can write NH3, after that CO2 and least is N2. Okay, is this clear? This is one point of understanding. Another point what I am saying, now solubility of a particular gas depends upon its partial pressure. Okay, so this is what Henry's law says. So it means how much amount of the CO2 gas is dissolved in the liquid depends on what is the pressure using or what is the pressure exerted by this CO2 gas. Okay, so I can write P gas, partial pressure of gas, is equals to KH X gas. What is this KH and all? See, partial pressure of a gas is directly proportional to solubility. Solubility is nothing but amount of that gas present in the liquid. That's it. Now that is nothing but the concentration of this gas. Okay, that is amount of a particular substance present in the water is nothing but its concentration. Okay, so now concentration can be expressed with different concentration terms like molarity, normality or mole fraction also. Particularly when we are discussing about Henry's law, mostly we will be using mole fraction. What is the term? Mole fraction. For example, if I want to write for CO2 gas, what I can write? Partial pressure of CO2 will be proportional to mole fraction of that gas, in the solution. Okay, so now this can be, I can remove this proportionality and I can replace it with a constant KH into X gas, that which gas it is? CO2 gas. Okay, like that, whatever might be the gas you are taking, that gas mole fraction you take. This side is that partial pressure of that gas. So KH is called Henry's constant. What I am saying, KH is Henry's constant. Okay, so the value of KH is a temperature dependent. What I am saying, KH is a temperature dependent. Okay, and look at these, how they are related. I want to get a relation between solubility of gas with the KH value. See, KH is a constant I am saying now. So for each gas there will be some values of KH. There will be fixed value of KH. Okay, so now what I am doing is solubility I want. Solubility of gas is equals to partial pressure of that gas by KH. Can I write like this? Yes. How do they relate? Inversely related. So more KH value, less solubility. For a particular gas, if KH value is more, its solubility will be less. If you want, it will be more clear with this one example. Look at this example. Gas 1 I am taking KH as 50 and gas 2 having 100, gas 3 as 150. Tell me, what is the solubility order? Very simple, more KH, less solubility. So more KH is here, then solubility order will be, gas 3 will be less, the next gas 2 and highest is for gas 1. So simply look at this value data and you can answer. See, there is a direct question from this. How easy it is? Yeah. So now one more thing, generally you tell me what happens If we increase the pressure, solubility increases. One more thing, if I increase the temperature, what happens to the gas? See, generally you just think that you have taken a container of liquid and you are trying to dissolve these gases. No, but you are supplying heat. If you supply heat, what happens? They will escape from here now. So solubility decreases. Okay. So if temperature is increased, solubility of gas. If temperature increased, solubility of gas decreases. Higher KH, lower solubility. More temperature, less solubility. Higher KH, lower solubility. It means if temperature is greater, KH value also greater, but solubility is less. You can relate this in this way also. Okay, and graph they will ask. How this graph can be? Partial pressure of gas and mole fraction of gas. See, y equals to mx type graph. Y, x, so m, like this. So what is our slope here? KH. That's it. Is this clear or not? Right. Let me show you few more things here. Few more questions like numerical questions, how we can expect from here. I will show you all the things. Henry's law is over. Can you answer me this question? Easy, you can try this and tell me. See guys, this is the EAPCET 2024 question. Very easy, already we have solved. In water, which of the following gas has highest Henry's law constant? Henry's law constant they are saying. HE you are saying more. Why? What we discussed, see, yes, that is correct only. Let us make it why it is more correct. See here, in water, which of the following gas has highest Henry's law constant? If solubility is more, Henry's law constant is less. So what we know, solubility is more if it is having more intermolecular forces. See here, we do not have any hydrogen bond, but if molecular weight is more, the van der Waals forces are more. Where do we have molecular weight more here? CO2. Okay, CO2. After that N2. And between helium and hydrogen, hydrogen will be relatively more soluble than this helium. So which is least soluble? Heliums are least soluble. So more KH value. That's it. Is this clear? And if I ask for the order, HE, H2, N2, CO2. CO2 will be having least KH value and more solubility. Right? Next. Look at this again. The order of KH values for gases A, B, C is given like this. KH of A is more, then correct order of the solubility. KH of A is more, then solubility will be? Solubility will be lesser. Okay, KH of A is more, solubility will be less for which one? See, KH of A is more now. It will be less. KH of A is more, the solubility of A will be least. Okay, and KH of B is least means solubility will be more. Solubility is more for B and least for A and in between C. So B, C, A we have third option. Okay, clear? Right. Can you answer me this? చెప్పు ఏంటి ఆన్సర్ దానికి? I will explain, no issues. So what they are saying, Henry's law constant Henry's law constant for dissolution of methane in benzene is this much. It means Kh is 2 into 10 power 5 mm of Hg. Okay. Then the solubility of methane in the benzene under 760 mm of pressure. What they are asking, then solubility of methane is how much? They are asking. Okay, what to do, tell me? Under pressure is how much? Pressure of gas is 760. So what to do here? See, once again, Henry's law constant for the dissociation is given as this much. Okay, then solubility of methane in benzene is how much they are asking. So what to do? Partial pressure of gas is equals to Kh solubility of that gas methane. Okay, so what is the data given here? What is the pressure given? 760 mm of Hg, and this side Kh is given as 2 into 10 power 5 mm Hg, and solubility they are asking. Okay, solubility of methane they are asking. So you can remove these two things, and 1 0 here, this will be 4 times, and this will be 3 8, 38 by 10 power 4. This is the solubility of methane, I can say, or you can modify this as 3.8 into 10 power minus 3. This will be the solubility of methane. Can we say it like this?
Yes.
Right. 38 by 10 power 4 means I can write 10 power minus 4 in the numerator. There we have option as 3.8 into 10 power minus 3. Is this clear or not?
Yes.
Right. Can choose option B. Next. Can you answer me this? Again, very easy NEET question. Tell me, what will be your answer?
Third option.
Henry's law constant values for 3 gases are given like this. The solubility of these gases in water will be more Kh, lower solubility. So which is having least Kh? This is 2 into 10 power minus 5 is least Kh, so more solubility for B. After this is 35 kilo, 35 into 10 power 3 bar. This means maximum value now. So minimum solubility for C, in between A. Option 2.
A is 140.
Yeah, A is 145 bar. This is 35 kilo bar, which is greater.
Sir, he told kilobar for every.
Okay, everyone. Okay, fine. So tell me now once again. This will be least value 2 into 10 power minus 5 into 10 power 3 bar. This is nothing but 2 into 10 power minus 2 bar. Which is the least value? That is lower Kh means
More solubility.
lower Kh, more solubility. So B is more soluble, and after this C here, because this value is lesser than 145, so C A. So where do we have? That's it. Clear now? Very easy. Based on this, Kh is inversely proportional to solubility relation.
Yes.
Right. Next one. Yeah. So can you answer me this question? Can you answer me this question? Very easy. Tell me what will be your answer for this. See, 20 ml of 0.1 molar HCl is added to 30 ml of 0.1 molar NaOH. To this, extra 50 ml of water is added. What is the molarity of final solution? Very simple. Whenever an acid and one more acid is added, you will get concentration of H plus ion with increment. But this is one acid and one base now. You need to take like this. M resultant will be equals to mv of acid minus mv of base plus V total. So what is the molarity of acid given? 0.1. What is the volume given? 20. Minus base is how much? Molarity is 0.1, 30. And V total is how much? This is 20, this is 30, 50. And to this extra 50 ml of water is added. So 100. So this will be how much?
1 by minus 1 by
Mod I have applied now, that's why. So just you can write it as 1 by 100. Is this clear or not? So this will be the M resultant solution. I mean resultant concentration. So what we can say, which is our perfect answer here?
B.
B. That's it. Clear now? Now tell me whether solution is acidic or basic. Salt is formed. Along with the salt, see, you are saying resultant concentration. See, if both of them are equal, we will get complete neutralization. But one is, this is 2 millimole, this is 3 millimole. So which is bigger quantity here? 3 millimole. So it means base formed will be, resultant solution will be now basic. Now whatever the value you got, that is nothing but resultant concentration of OH minus ions. Which one?
OH minus ion.
This NaOH concentration. So you got NaOH minus ion concentration as how much? 10 power minus 2, which is your answer. Okay. Now what I am asking is, what is the pH for this solution?
10 power of minus.
That is pOH is given now. So pOH, OH is given now. Find pOH from here first. pOH is how much? If OH is 10 power minus 2, pOH will be 2. How it will be? Minus log concentration of OH minus is equals to 10 power minus 2. So that is what? How we got this, man? See, minus log of concentration of OH minus, that is 10 power minus 2. So log 10 means it is 1, minus 2 I can write it as minus 2 into minus, so plus 2. This is pOH. Is this clear or not? The next, pH means what? pH plus pOH is equals to 14 at 25 degrees Celsius. Okay. So here I can say 14 minus 2, that is 12. This could be your answer. Is this clear? Right. If the things are clear, let us move forward. Tell me what will be your answer for this solution? Very easy. Based on concentration terms. Yes, tell me. Just tell me what is your answer for this? ఏమడుగుతున్నారు ఇక్కడ? Molality, small m is equals to number of moles of solute by weight of solvent in kgs. If it is kgs like this, if it is grams, multiply with 1000. How many moles given? 1. Weight of solvent is given as how much?
50 grams.
Into 1000. 20. So what is your answer? 20.
Yes.
Next, answer me this. Okay, and you can try this other ways.
8%.
See, what I am asking, very simple na, temperature dependent. How can you say temperature dependent and independent? If there is a volume term involved in the formula, then you can say it is temperature dependent. So molarity, number of moles by volume, temperature dependent or independent? Volume term is involved, so it is temperature dependent. Next, mole fraction, number of moles of solute by total number of moles. Do we have any volume term? No. So this is no. What about this? Weight of solute by total weight of solution? No. No molar. What about this? Molality means number of moles of solute by weight of solvent. Do we have volume term involvement? No. So not in this case, only in molarity. Is this clear? Tell me for normality.
Dependent.
Why?
Because by volume.
Number of gram equivalents by volume.
Yes.
Okay. Tell me your answer for this question. What will be your answer?
200 ml solution of what? Salt water.
NaOH. If a 2 grams of NaOH is dissolved to make 200 ml of solution, like NaOH solution at 25 degrees Celsius, okay, we will get some molarity now at 25 degrees Celsius.
Yes.
Similarly, same solution is made at 90 degrees having concentration M90. So now they are asking whether this M90 degrees and M25 degrees will be equal or which is more, which is less. Okay, tell me what's your answer?
Number of moles you have to find.
Find number of moles. So tell me, generally molarity formula is nothing but number of moles of solute. What they have given? 2 grams of NaOH. Given weight is 2 grams. Molar mass of NaOH is 40. We will get number of moles into what is the volume mentioned? 200 ml. So 200 in the denominator, numerator is 1000. So this will be how much? 20. So now remove these 3 zeros like this. So you will get 1 by 4. That is nothing but 0.25. Molarity at 25 degrees Celsius is 0.25. So what we know at 90 degrees, if we want to get, molarity is inversely proportional to volume, right now. So if temperature is increased, so volume increases, expansion takes place. So volume increases. If volume increased, molarity decreases. So what we can say, molarity at 90 degrees, M90 will be less than M25. At 25 degrees, how much it is? 0.25. Okay, M90 will be less than 0.25. Where do we have? First option. Clear or not? Right. Tell me what will be your answer for this question. If what is the molarity of NaOH having NaOH solution having 4 gram per liter? Tell me, what is its molarity?
0.4.
Very simple. Molarity means what is its units? moles per liter. What I have given?
grams per liter.
So just converting grams per liter into mole per liter will gives you an answer. So how can we convert? Molarity equals to given weight of solute by its molar mass of solute into volume in liters. Right now. So what I have given its weight and I have given its volume. These things are there, but we need to have this molar mass, that's it. So molarity will be equals to, see, gram per liter is there now, we can call it as strength of solution. What is that?
Strength of
So strength of solution is given. So given strength of solution by its gram molar mass or molar mass will gives us molarity. So what is strength of solution? 4 gram per liter. So divide this with molar mass of solute. What is the molar mass
40.
of NaOH? 40. So what will be your answer? 0.1 mole per liter. This will be your answer for the question. Clear? Next. Write a question. Write a question and tell me the answer. Okay. When 4.9 grams of H2SO4 sulfuric acid is added to water to make 500 ml of solution, the molarity of solution is how much? Dash. How can we do this?
The sulfur sulfur mole.
Tell me what is the answer for this? See, simple molarity na. So molarity equals to what you can take, number of moles of solute by volume of solution in liters. Okay, so but it is given in ml, so you can take number of moles of solute by volume into 1000. So you can express your volume in terms of ml now. So what is the number of moles given? They have given it as weight. So take 4.9 grams by its molar mass of sulfuric acid is 98. How much? 98, that's it. Into 1000 by 500. So this will be 2 times and this will be, see, you can write 10 power minus 1, this will be 2 times again. So we will get molarity as how much? Molarity is 0.1, that's it. Is this clear? Now they will ask, instead of asking molarity, the next step question is pH. What is the pH of solution? For the same thing, they will ask what is the pH of solution. How you will be answering this? See here, when they ask pH for sulfuric acid by giving molarity, always remember, whenever you are calculating pH, concentration of H plus must be mentioned in terms of normalities, not in terms of molarities. Because for sulfuric acid, it's a dibasic acid now. So how many H plus ions comes from this? 2. Okay, when it is dissociating, we will get 2 H plus ions. So what is the resultant concentration of this in terms of molarity, normality? Normality equals to molarity into its n factor. What is the n factor? 2, because number of ions released H plus ions are 2. So this is 0.1 into 2. So normality is, so H plus ion concentration is 0.2. So minus log of 0.2. Okay, how much it is?
2.
How you will write? 2 into 10 power minus 1 if you write. So 1 minus log 2. This will be your pH.
Yes.
Okay, 1 minus log 2 is how much? 0.3010. Taking 0.30 for simplification purpose. So this will be 0.7 is a pH of this resultant solution. Okay, right. And one more thing, always if they give acid and asking for pH, directly you can calculate. If they ask for pOH, what to do? First find pH, then after pH plus pOH is equals to 14, from that you can get. Okay, now tell me what will be the pH of 4 grams of NaOH dissolved in 100 ml of water. Tell me resultant pH for this. What is the resultant pH of this solution? First of all, what to do? First, what we need to do? Find the molarity of the solution, that is concentration of OH minus.
13.
See, OH minus ion concentration, how much will get? Molarity or normality is same here because its n factor will be 1. So how much it is? 4 by 40,000 by 100. Okay. So the next molarity is 1. Okay, is this clear up to here? If molarity is 1, so what to do the next? pH plus pOH. So first find pOH. So pH will be almost nearly equals to 14. Okay, this is the way. This is clear? First find, you got OH minus ion concentration here. So from this you can get pOH. After that you find pH using pH plus pOH formula, right? And one last question I just want to give you is, find molarity of, not always molarity, let us find mole fraction of solution made by mixing 3 moles solute and 6 moles solvent. Very simple question. How can you find the mole fraction? Tell me.
Sir, both are liquid or solid?
See, I am just saying it is a mole fraction of solute I want. There is no discussion of liquid, solid.
No, the volume of the moles of.
What is the discussion here? What is the mole fraction formula? Mole fraction. Fraction means what you need to take. If I am saying B is a mole solute, mole fraction of solute is nothing but number of moles of solute in the total number of moles. That is N total is nothing but Na plus Nb. That's it. Tell me now at least. Direct formula substitution.
1 by 3.
Number of moles of solute is how many? 3 by 3 plus 6, 9. 1 by 3. You can say 0.3. Okay. Number of moles of mole fraction of solvent if I ask?
0.66.
So 6 by 9. this is 2 by 3, this is 0.66 or 67 you can write. Okay, and from this what you got to know? Sum of mole fractions will be equals to sum of mole fraction, just to you add this mole fractions is equals to 1. Okay, by knowing one mole fraction we can find other, because mole fraction is a term we will be using more in this solutions chapter in Raoult's law and everywhere. Okay, that's why I am giving this. Okay, right. Yeah, so this is about the session. So in the next session we will be discussing about Raoult's law, ideal solutions, okay, and vapor pressure, effect of temperature and vapor pressure. These things we will be discussing in the next class with the PYQs. Okay, right.